Okay, what is our universe actually made of? I mean, really, it's one of the biggest questions out there. And the answer, well, it might be a whole lot weirder than you think. So I want you to just forget what you think you know for a minute, because we're about to dive into a radical new idea that could literally rewrite the rules of reality.
So, get this. Imagine for a second that everything, you, me, the stars, the planets, is all just part of a single unified fabric. And no, I'm not just being poetic here. This idea, this fabric of reality, it might just be the key to solving the biggest, most stubborn puzzle in all of modern physics.
Okay, so to really get a handle on this puzzle, first you gotta meet the two reigning kings of physics. You see, for the last 100 years or so, pretty much everything we understand about the universe has been ruled by two wildly successful theories that just so happen to be totally fundamentally incompatible with each other.
So in one corner, you've got general relativity. This is Einstein's baby, right? His masterpiece. It's this beautiful, elegant set of rules that runs the show on the grandest scales imaginable. We're talking stars, galaxies, the whole sweep of space-time. It tells us gravity isn't a force, it's just the shape of space itself bending and warping. Then in the other corner, you have quantum mechanics. This is the wild, chaotic, totally bizarre set of rules for the super small world of atoms and particles. And here's the thing, both of these theories work perfectly in their own domain. They're unbelievably successful. The problem? They absolutely cannot stand each other.
And here's where the real problem kicks in. Even though they both rule their kingdoms perfectly, the way they see reality is just completely different. One describes a universe that's smooth, continuous, and predictable. The other describes a universe that's all jumpy, weird, and based purely on chance. I mean, they just can't both be the final word on how things really work, so which one is it? And look, this isn't just some abstract philosophical argument for physicists to have over coffee. There are actual places in our universe, like the insane crush at the center of a black hole, or the very first instant of the Big Bang, where the super big and the super small are crammed together. And when we try to use both of our theories to figure out what's going on, the math just completely falls apart. It spits out nonsense, like literally infinities. It's like a giant flashing neon sign from the universe saying, nope, you're missing something big.
So, for decades now, the holy grail for physicists has been to find what they call a theory of everything. One single beautiful theory that can finally bring these two warring kings together under one roof. And for the most part, there have been two main strategies for trying to force that peace treaty.
So, how do you do it? How do you get them to finally agree? Well, for a long time, the main strategy has been to basically make one theory give in to the other. Path number one, which is the most popular, is to quantize gravity. Basically, you take Einstein's smooth, flowing fabric of space-time and you chop it up into tiny, discrete little pieces, forcing it to play by all the weird quantum rules. The other path is to do the exact opposite, to try and find some deeper geometric truth that makes all that quantum weirdness just go away.
But here's the thing, after decades and decades of brilliant minds working on this, neither path has really panned out. We don't have a confirmed theory. So, what if the whole approach is wrong? What if trying to force one to become the other is the big mistake? This is where we get to explore a third, much more radical path.
Now, this is a seriously bold statement. The argument being made here is that quantum mechanics, as amazing and successful as it is, just isn't the final answer. It's more like a signpost. It's great at describing what happens, but it doesn't really tell us why. It's a description of the effects, not the fundamental cause.
So instead of trying to break general relativity to fit into a quantum box, this new idea says we should do the opposite. We should double down on it. The fundamental insight from Einstein, that the universe is all about geometry, is right on the money. It just doesn't go far enough. You could say Einstein's theory is brilliant, for sure, but maybe it's just an incomplete piece of a much deeper picture.
And this, right here, brings us to the absolute heart of this whole idea. The goal is to finish what Einstein started. He turned gravity into geometry. This theory tries to do the same for everything else, starting with energy, by completely rethinking what that fabric of reality actually is.
Okay, so geometrization. What does that word even mean? It sounds complicated, but the idea is actually pretty simple. Remember how Einstein showed us that gravity isn't some invisible force pulling you down? It's just the shape of space itself, curving around a big object like the Earth. You're not being pulled to the ground, you're just following the curve in space. Well, this new theory says, what if everything works like that? What if an electron isn't a tiny little ball sitting on the fabric of reality? what if the electron is a tiny complex wrinkle in the fabric itself? So here's the new recipe for reality broken down. Step 1. Just assume there's only one thing in the universe, a single, unified, elastic fabric. Step 2. Every particle you've ever heard of, from an electron to a quark, isn't a little point-like dot. Instead, it's a stable, complex wrinkle in that fabric. And step 3, the big payoff. This means a particle's energy isn't some mysterious property it carries around, it's just a measure of the geometry, the shape of its own little wrinkle. More energy simply means a more complicated wrinkle. Simple as that.
And if this is right, this is the really beautiful part. The whole conflict just disappears. It just vanishes. General relativity becomes the view when you zoom way out. You're just seeing the big, gentle curves in the fabric. And quantum mechanics? That's just what you see when you zoom way, way in. And you're looking at the wild, chaotic behavior of all those tiny individual wrinkles. They aren't two competing theories anymore. They're just two different perspectives of the exact same geometric universe. Two sides of the same coin.
So I'll just leave you with this one last thought to chew on. If every single particle, every star, every galaxy, if all of it is just a complicated wrinkle in one single universal fabric, what would happen if you could just smooth it all out? What does a perfectly flat, wrinkle-free reality even look like? That's the kind of mind-bending question that could change how we see, well, everything.